We're gonna talk about writing code in production. My name is Sam Wilson. I'm from Philadelphia. Welcome to Pittsburgh, the other fair city in the state of Pennsylvania. I hope you're all enjoying day 2 of Abstractions and having a good time. So, as I said, I'd like to talk to you today, kind of start a conversation about this idea of writing code in production, why I think it's important, and how I think this could be really helpful to you as you kind of build your applications. And use the clicker. To be clear, we're going to talk about writing some code in production, right? I'm not completely crazy, and if you came with a pitchfork or something else to kind of cart me away because you think I'm crazy, I'm not talking about writing all your code in production. Some of your code in production. Because I bet you don't write any of your code in production today. So let's see if we can find some nuance here. A little bit more about me. I'm CTO of a startup in Philadelphia called Bainbridge Health. We help hospitals manage medications, how they administer those safely and make sure they don't run out unexpectedly. My background also includes work in other kinds of industries with varying levels of regulatory control, payments, education, finance. I've also worked in marketing, automation, e-commerce, and online media. And later on, if you want to give me nice words or bad words on Twitter, you can find me at NumSafari. So in my career, I worked on a lot of what other people kind of think of as boring problems, like getting paid or paying bills or complying with the law or making sure that things are secure, but not in the fun way where like there's hackers and things like that, but more like the unfun way where you have auditors from Deloitte and Touche who don't know anything about computers, but they want to go through spreadsheets, and you're like, security by spreadsheet. I get it. So due diligence and things like that. And what I've kind of come to find is that these boring problems, in a lot of cases, are actually how a business innovates and becomes successful. That if you can be better at how you get paid, if you can be better at how you control costs, if you can be better at how you comply with the law so that it's not so burdensome on your organization, you can actually innovate as a business and be really successful. So you might have a really cool app, and then eventually you get bought by the company that has the less cool app, but a way more cool back office. That's the kind of thing that happens. And lately, I've really been focused on thinking about change management. This is kind of a boring topic when you're thinking about it from the perspective of AICPA, SOC2 audit, regulations, or ISO 27001 and things like that. Super boring stuff. Security by spreadsheet. But when you start talking about things like continuous delivery or DevOps or GitOps, it kind of gets kind of cool. And you're like, oh, this is really neat stuff. And so kind of the question is, how can you innovate in change management to create competitive advantage for your organization? Or just to be more effective as an organization if you're working in not-for-profits? So I don't know how many of you have maybe seen this book? Okay. I was expecting more hands. So this came out last year, and I think it's a really amazing book, and I would highly recommend that all of you actually go and check it out and read it, because it's really full of amazing information. Basically, the folks at Puppet Labs have been doing a survey over the last several years called the State of DevOps survey, and with that, they kind of coordinated with some researchers, and they collected a bunch of data across a broad swath of industry, teed that up with some market data that they pulled together. And I think what they've produced is probably the most important piece of quantitative research in software engineering, probably ever, because it's so comprehensive. This isn't like a lab experiment with 10 undergrad students doing Agile. This is a real broad survey across industry. And what they found over time is that there are different kinds of organizations that exhibit different kinds of traits, and they tend to do a lot better. They talk about high performers. So basically, through all this data, they did a rigorous analysis, and they basically identified organizations that exhibit certain similar traits, have certain similar outcomes. They have greater commercial success, so their market cap growth, their profitability, their market share growth outperform other organizations that exhibit different traits. They also have greater non-commercial success. So they're more effective. If, for example, they're a not-for-profit and their goal is to achieve certain outcomes, they're more effective than their peers. They're more efficient. They make better use of the money that they take in. And they have higher degrees of customer satisfaction. From a management perspective or an engineering perspective, they exhibited certain traits very consistently. And what they found is that these organizations were both faster and more stable, which was fairly groundbreaking in terms of actually having data to back that up. We usually think of, cowboy coders and things like that, break all the rules in order to go fast and, break things and move fast, right? Except these organizations also have better stability. They've got lower mean time to recovery. They have lower change fail rate. So when they deploy something, it's more likely to be accepted by their users and just continue to be a part of their application. They don't have to roll back changes or apologize in public quite so often. How do they do this? Well, go figure with DevOps. They don't necessarily call what they do DevOps, but it's a fairly useful term at a high level, so we'll kind of stick with it. And basically what it comes down to, if you go and look up DevOps on Wikipedia, basically integrating your development operational practices to shorten your software development lifecycle, be better aligned with business outcomes. To paraphrase Twitter, automate all the things, right? It's maybe something that you've heard. A key aspect of this is continuous delivery. So a lot of organizations are trying to achieve continuous delivery as part of their DevOps practice. How many of you would say that your organization uses continuous delivery today? It's a good number of hands. How many of you are trying to implement continuous delivery today? It's like even more hands. Awesome. So there's more to continuous delivery than automation and technical things, right? There's business practices and organizational practices that you need to adopt in order to achieve continuous delivery. We're going to focus on some of the technical aspects of continuous delivery. So again, the goal of continuous delivery is to, as quickly and efficiently as possible, get changes in front of customers, right? The longer something sits in a branch somewhere that nobody's looking at, the longer it's going to get stale. Business environment's going to change. The user environment's going to change. If you're working in a not-for-profit world, you might be out there trying to deal with a disaster scenario. And that disaster might get worse or resolve itself before you ever release changes. And what good was that? And I think another thing to keep in mind is that these changes don't magically just ride into production, right? There's still approval processes. We still have to do testing. We still have to have user acceptance before we deploy something out into production. We still have to do staged deployments. So I'm sure all of you are kind of familiar with this idea of having dev, stage, and prod. There's kind of an acronym, go figure. We have an acronym called DTaP, Development, Testing, Acceptance, and Production. So most of us probably have a dev, stage, and prod, or a dev, test, prod kind of setup. That's what I've been mostly familiar with. I've also seen organizations that have double digits in their deployment environments. That's usually the result of some kind of training or auditing program that they have, or lots of middle managers who all want their own environment. And more or less, like your development environment, that's where you write your code, or that's where you test your code before you actually hand it to your QA people. It's where you can go and be creative, and you can explore all of your flights of fancy. You can say, I want to try this new tool, and I want to see what that looks like, and throw all caution to the wind because, hey, it's your environment. You have your testing environment because you want to be able to make sure that you don't break things before you deploy your code. Maybe you want to be able to do load testing without taking down production, or maybe you want to verify that you can do your data migrations before you actually run them in production so that you don't accidentally sneak in a truncate table into your data migrations. Lived through that. Eventually, some of us all have an acceptance environment, right? And so this might be like a pre-production environment or a demo environment where you can show changes to a subset of customers before it actually hits production, before everybody experiences it. Why do we do this? So there's some common sense reasons why we do this, right? Like this isn't just something that, is magic. We do it to maintain stability, right? We don't want developers out there just crashing production willy-nilly. We don't want, to introduce errors and things like that. We want to maintain a stable environment for our users. We want to maintain security, right? So developers usually have full access. I mean, how many of you have root access on your laptop? Right? Hospital IT departments are all rolling over in their graves because they cannot stomach the idea of anybody having root access on a device. So most developers have root access to the device they work on. They have root access in the development environment they work on. So if they have the ability to change the code that controls access, if they themselves have root access, then any data or anything else that goes into that dev environment, they can just modify that or see it or do whatever they want with it. So one reason we have these staged environments is to have different ownership and different controls for different levels of security. Maybe you also want to maintain secrecy. So you might have features that you want to roll out, and maybe you want to kind of keep those internal before you show them to all your users. So that's another reason you might want to have a staged delivery. How many of you have seen the movie Office Space? Right? So kind of like the plot line of that movie, other than like all the funny sort of like office scenes, it's basically there's this group of developers and they introduce a change where they can steal fractions of a penny from every transaction. At least that was kind of like the idea. Right? So developers have a lot of control, and we don't necessarily, in an environment like their development environment, we wouldn't want the bank running in development where the software engineers can just route all the transactions to their own account, whether it was done on purpose or by accident. At the end of the day, this comes down to wanting to maintain control, right? Like we want to maintain control. We don't want people just changing things willy-nilly, and we want to have some sense that we know when things are going to change and have some control over that. This is also mandated, right? So it's actually mandated in certain industry and legal frameworks. Sometimes it's explicit, but most often it's implicit. There's an implication in a lot of the security and legal frameworks that you work with that just assume that you're doing some kind of staged deployment. So one example is there's this organization called the Cloud Security Alliance, and they have a security framework, one of those spreadsheets that'll keep us all secure, called the Cloud Controls Matrix. And if you pour through that thing, there are a few references to production and non-production environments. It doesn't ever say, hey, you should really have a test environment before you go and crash production. People shouldn't be editing their code in prod. It just assumes you're that smart. And it assumes that you're also, it then goes further and says, and by the way, that production environment should be secure and separate from all your test environments. Like you need to have those kinds of separations. Another one, implicit, this is in the healthcare space. Test data shall be selected carefully and protected and controlled in non-production. I think this one's really interesting because not only does it imply that you should have a production environment, it also implies that you're copying data from production, sensitive data, elsewhere, and you should be really careful about that. Meanwhile, I have found that healthcare organizations are the ones who are the most freaked out about this. So I think that's kind of funny. Lastly, the payment card industry, these guys are a little more with it, I think. But they basically say, hey, you got to keep these things separate. You really shouldn't be copying data, and controls should be independent. One example of an explicit industry standard that calls this out is COBIT 5, and it actually does say, oops, no, I hit the wrong button. Is it playing? No, there we go. All right, don't want to reveal my secrets. Yeah, it actually says right here, establish a test environment, right? Like that's part of the standard some organizations want to hold themselves accountable to. So again, if you go back and you look over this, it's not so much about you having staged releases. It's more about making sure that you are not copying production data out of production into other environments. It's about making sure that you're enforcing controls all along this delivery pipeline and you're keeping things secure. That's really what everybody's concerned about. If you've got 20 delivery environments, if you've got 2, they don't care as long as you're not copying production data. That's really all it comes down to. So hold on. We know that we want to have these controls, and we know that most developers actually don't do this, right? Because otherwise everybody wouldn't be asking these questions. People wouldn't be freaking out about this. So if it's common sense, why is it that this happens? What's going on here? Well, I think it's for a couple reasons. One of them is when we learn to code, generally speaking, we don't learn to code in an environment of controls, right? We learn using tools like Swift playgrounds and things like that, where we've got these fast iterative setups, right? You've got a REPL, and you can just edit code, and you can immediately see the results and show it to your friend. Or if you're like me and you're a little bit older, maybe you learned using a basic interpreter, right? Like, love that blue color. Anyhow, maybe if you're into data science, you might have started out using Jupyter Labs or something like RStudio. That's maybe the environment that you learn how to code in, right? There's nothing in here about dev stage and prod. It just doesn't exist. It's not part of the equation. So when we're learning, this is the environment that we're familiar with, right? We're really used to this experience of, as a developer, I make changes, I show it to my user, they give me a grade, right? So we've been trained through gamification all through our education, whether it's in college or a boot camp, that basically we just deploy changes and somebody gives us feedback. And we love that. It feels really good. Then we get our first job, and it's a little bit more like this, right? I'm a developer. It goes through a whole big, scary change management process. Eventually it gets to a user. There's some guy somewhere who's probably intermediating between the developer and the user for another Office Space reference. And then eventually, like the user, right? Like user feedback has some kind of whisper down the lane process that eventually shows up in a Jira ticket or a GitHub issue. And we don't know this user. They could be the person that we flipped off on the highway on the ride into work. We've got no idea, even though they're paying our bills. Another problem, I think this is a little bit more of a challenge for folks, is bootstrapping. Say I need to build a report as part of a work assignment. How do I build that report without some sample data, right? Or if I'm doing something really exploratory, the requirements are in the data. Nobody may know the answer to what it is we need to build until you go look at the data. So oftentimes, what do? We copy data back from production to somewhere else. How many of you have a process to copy production data back to your test environment? I have too. Right? It might be for load testing. It might be so that you can verify that your data migrations look proper. You might even tell yourself that you do this because you want to verify that your backups are working. Right? What's better than making sure that your production backups are working than doing a restore every day into your test environment? Hey, look, it works. And we ran tests against it to prove it. So one approach to kind of solving this problem is to use sampling, right? Let's take a sample of production data. And you can do this either horizontally or vertically, depending on how you want to think about it, where you take a subset of the data, maybe you chop off a bunch of rows and you say, I'll just give you a day's worth of data, right? I'm managing my risk exposure if I only give a developer 1 day's worth of data. Or maybe I can de-identify the data. I can chop off certain columns, or maybe I hash those columns or something like that, so that you can't really see that data. But there are some problems with this. One big problem with this is, that PHI or PII may still leak out. It can leak out in unstructured fields like notes and things like that. There might be a note in there that says, John, customer ID, blah, 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 called to let me know that his social security number is X. And you might have masked the social security number and the username and their user ID. You might have done all the right things, but then these pesky notes. So never include the note fields unless you're trying to do natural language processing, in which case, throw caution to the wind. Another problem is scaling, right? Laptops aren't data centers. So you've got developers writing code out on their laptop, and it's not representative of the size of the data or the production environment that you're going to deploy to, right? You're going to run into problems where, I/O bandwidth or memory bandwidth might become a real problem, and something that worked really well on a day's worth of data falls completely apart when you try and process 3 years of data across your entire customer base. Another issue is, why do you want data all over everyone's laptops? I work with hospitals, and I tell you what, the number of times I'm sitting down with a nurse manager or a pharmacy manager, and they just bring up a spreadsheet chock full of PHI, and I'm thinking to myself, man, you guys just email that to each other. And they won't even give me access to like a de-identified database that's going to live in their data center. But this data is all over everyone's laptops. And it should freak you out, because that's what ransomware is all about. So the other thing is that this doesn't scale from like a business perspective, right? There are surprises in the data that you might be missing. If you look at a day's worth of data, you might miss out on things like end of year issues or maybe something special only happens in the month of March or April, like filing taxes. And if you're looking at June, you might miss out on all those transactions. And that might end up breaking your code, right? So sampling has its own issues. And so I think at the end of the day, like the question is like, why is the report treated the same as the rest of your application? Why can't we do proper exploration in our actual application that's living in production, right? Why do we have to go back to a developer's laptop? Why isn't our production application powerful enough to enforce controls and support this kind of discovery? What if we took you to production instead of production back to your laptop, right? And so what do I mean by that? I mean, how about we embed customizability into our applications? Things like macros or plugins or extensions. There's this term, internal reprogramability, right? Like as developers, we use tools all the time where we're writing code in someone else's production. If you think about it, when you're inside your web application, you fire up any web application today, start interacting with the client-side JavaScript, change whatever you want. There's whole, ecosystems of tools around this. Or maybe you use Emacs, right? Your Emacs editor. You just fire that thing up and completely customize your environment. You may be surprised to hear that in the most enterprise of enterprisey spaces, ERPs and EHRs are almost entirely delivered as source code to their customers. This is very prevalent because customers want to completely customize these things. I worked for one company, their entire ERP system was literally SQL stored, or Oracle T-SQL stored procedures. That's what they delivered customers. Our web server ran in Oracle. It was T-SQL. So imagine being the front-end engineer writing T-SQL. Felt bad for those people. So what if we had a develop mode in our applications, right? Most of our web app boilerplates include some kind of admin console, right? Because you sit down and you're like, oh, I want to build a web app, and of course I'm going to have like a bookstore, and I'm going to have books and all these kinds of things. But then I'm going to need some other experience for the admin who can go in and add products, or maybe edit landing pages, or customize certain templates for email campaigns and things like that. Maybe they should also have a develop console, right? Where you can go in and you can edit plugins or little customization change points within your product. Embed an IDE, like a small IDE, or even a full-fledged IDE, or just have a Git repo that contains extension points for your production application and embed that in your production application. This has some challenges, right? Like you don't want to let users just upload raw C code or whatever to your production environment that's not somehow constrained. We haven't completely lost our minds. When you have a web application, the code you download from the internet runs in a sandbox, right? You're letting websites run code in your production, your laptop with all your personal information. Think about that, right? Like this laptop, that's my personal production, has all my passwords and keys and banking information and all sorts of stuff in here. And when I download a web application, if I download a toolbar plugin, if that thing's not running in a sandbox, it could be doing anything. I could download a cool, image macro editor, and it could just be in the background uploading all my contacts, right? So we want sandboxes. So you have an application shell, and inside there you have things like your IAM, your UI, maybe your data management, and your default business logic. But then you have sandboxes. And in there you can put little experiments, just little experiments. You still have to maintain security and data integrity. You still need to be concerned about things like resource exhaustion, right? Like if you let a user create a loop, they'll create an infinite loop. Just give them enough time, right? And if you don't have the right controls in place, that's just going to spin off, and eventually you're going to run out of something. It might be, CPU, it might be file handles, it might be something, right? They can still introduce bugs, right? Somebody can introduce a bug. Like you don't necessarily want to let people, SSH into the Gibson and just change anything. And so at the end of the day, you still have to be worried about change management in production, right? So maybe you've got a nested set of change management. So I wanted to kind of present some strategies that I think you could take on in your application development that might help you kind of get towards this. One's functional core and imperative shell, and we'll just run through these. Functional core imperative shell, it's a phrase coined by this guy Gary Bernhardt, who's got a series of podcasts and talks called Destroy All Software. And the basic idea is that your application core, right, is implemented in purely functional logic. It makes no mutations, right, directly to like the real world. The application shell can be so the idea is take your application shell, the imperative part, and make it so that that thing can't be changed in production, but maybe you can change your imperative core, right? So maybe you've got certain kinds of control logic and things like that are your imperative shell that are stable and go through rigorous testing and rigorous deployment. But then maybe you can edit this the functional core in production. So refactoring your software. The other is, and probably the most powerful, is declarative programming, right? SQL statements, configuration files, business rules. Tell the shell what to do, not how to do it, right? If you just modify some configuration, then you can do that in production. I bet lots of you have already done something like that or seen something like that. I worked for a media company. We wanted to be able to do things like on Friday at 6 p.m., change the public website to be something to announce a new show that was going to come out that weekend. Right? It's all part of our marketing thing. People would go into the production environment, they'd make a bunch of changes in the database in order to make that happen. And that's just configuration, right? It's just business rules. Another thing that you can try and achieve is immutable data. And when you're working in data science, you're generally dealing with really large sets of data. So I would suggest that you have data pipelines that are non-destructive, right? Basically, each stage in your data pipeline produces some new set of data rather than modifying an existing piece of data. You can leverage tools like Pachyderm. If you haven't heard of Pachyderm, I highly recommend you check it out. It's probably the most publicly well-known product like that for data lineage or data governance, but basically lets you treat your data pipelines in an immutable fashion. Another benefit of this is you can quickly promote data you've built in stages in your production environment when you go to production, kind of like a Git Merge. It's a really powerful concept. But one problem with this that you'll kind of run into is this idea of aliasing. If I've got different branches where maybe I've got a data pipeline that goes from some raw data to let's just say like a daily metrics file, and then I have a dashboard that consumes that daily metrics file. But then in my branch, I've got daily prime, right? Somehow I need my dashboard to know that it's got to look at daily prime and not the actual daily. So something to kind of think through with your templating. So maybe you don't just have SQL, maybe you've got to do some kind of SQL templating so that it knows how to insert which table to actually look at. Don't look at the production daily, look at the modified daily on my branch. Lastly, traffic routing. You deploy these changes up into production, right? And now you want to be able to make them accessible to end users. So maybe you've got a URL parameter or a JWT capability that expresses which branch that user is sending their request to interact with. If you're using like a Django application, let's say, this could be implemented in middleware pretty easily. If you're using a service-oriented architecture, you may need to use something like a service mesh in order to make sure that you've got full isolation, right? Because if service A is going to talk to service B and it's like, hey, use business rules from branch X, you've got to make sure that that's going to flow through. And one way to do that is using a service mesh. So some prior art on this. Try and get through this real quick. Looker is a BI tool that does this. So if you kind of want to see an example of something like this, I'd highly recommend you look at Looker. CMSs, a lot of CMSs have the ability to stage content changes that you're going to deploy to production. And marketing automation tools like Optimizely or Monotate. I bet your marketing department is writing code in production right now that you've never seen. And it comes in the form of Optimizely 100% tests, right? Where everybody's in the test group. And they're just saying, hey, we wanted to change this logo and we didn't want to wait for the developers to kind of get their act together. So we just did it with Optimizely, right? When I worked at Monotate, that's actually how we sold Monotate a lot of times was, hey, CIO, you can actually let your marketing department make all these changes and it won't show up in your backlog. Why isn't this a PaaS, right? Like, Sam, what are you talking about? This is just a platform as a service, right? And it shares a lot of similarities, but you probably shouldn't build your own PaaS. I think the big difference is that a PaaS, generally, you're going to allow yourself to write all sorts of like low-level code, right? You're going to be able to edit that function or the imperative shell. And here we're just talking about being able to edit the extension points. So start small. Use features like feature flags or business rules or marketing automation tools and explore with your existing application how can you do things like coding in production, right? Maybe you've got a business rules engine or maybe you want to introduce one. And that's a way that you can start small in an existing application. Your configuration is code. I bet lots of you have a database table somewhere in your application that's actually a configuration file. So why not take that configuration, take it out of your database, and make it a file that you have in version control? And then go one step further and move it into its own Git repository. And then go one more step and move that repository into production. Now you've taken your configuration, you've turned it into code, and you can manage it in production. So that was kind of the story. Thank you guys for sitting through it. We'll do QA outside.